the end of the last video, we're putting the edges in for our new representation of G1. So let's take a look at that. So we need to put UV in. We need to put UW in. We need to put VX. We need to put VW. And we need to put WX. And remember what we're trying to do. We're trying to show how these two graphs might be the same, how I could relabel this to get the same graph as this. And it's not clear from the original drawing that that could be true, but when we look at this drawing, you almost, you can pretty much see how it's going to go. So we could actually now just roll it over because we can see that this graph is just this graph on its side, or this representation is just this representation on its side. And so if I rolled it over, so this would be U, V, W, X, and put all the edges in. It looks like this, and now we can see that these two things are exactly the same. And this tells us one way we could write an isomorphism. So U would go to D. So I'm just matching it up with the picture down here. You could also roll it the other way. There's more than one option here, but this is one of the ones that work. U could go to D, X could go to A, V could go to C, and W could go to B. Okay, so this is our candidate for our bijection. This is our isomorphism candidate. So this is literally the directions on how to do it. So first, let's notice we have a bijection. Between our two sets of vertices, UVWX is the domain, and then ABCD is the codomain, and everything is represented in the range. Okay, so notice we have F is a bijection, and then 2, now we need to check that the edges are preserved. Which means that all of these edges via F end up mapping to one of these edges. And so remember how it was written in the definition. It was something like, if AB is in E1, then F of A, F of B is in E2. Right? So this is what we're checking. So how do we check that? So let's take UV and think about where the edge is going to be sent by F. UV goes to DC, because U goes to D and V goes to C. And that shows up here, that's labeled as CD. Right. So this is really CD. DC and CD are the same edge. And then F of UW is equal to D, and then W is B. And if we write them in alphabetical order, that's BD, so that's this edge here. And then we'll keep going. F of Vx is equal to, well, V maps to C, X maps to A. So we can flip them around, that's AC, and we can go back to our original, our E2 edge set, and see that it's represented there. And then let's just keep going. So we've done through Vx, let's do VW. VW, V goes to C, W goes to B, and we're out of order, so let's put them back in order. And then the last one is, oh yeah, and notice that it's here. And the last one is Wx, W goes to B, X goes to A, so this is AB, which is the last edge in the edge set for G2. So notice that when we send the edges from G1 to the edges to G2, we get exactly the edges in G2. So this is a bijection. So this is an isomorphism. And what we write, the way we write that these two graphs are equivalent is that G1 is equivalent to G2, and we read that we read this by saying G1 is isomorphic to G2.